In this video, I'm going to talk about diffusion models. And a diffusion model is based on the observation that when new technologies or products are introduced to a market, they tend to follow an S-curve. What do I mean by an S-curve? Well, in this chart, the horizontal axis is time periods, and for this type of analysis, these are usually years. Sometimes they can be quarters of a year, but generally years. And on the vertical axis is the percent of market adoption from 0% to 100%. And what I show here is a couple adoption rates, stylized adoption rates for different technologies. And you can see one thing that's common is that they follow this S-curve. There's a slow adoption rate, then it picks up, and then it saturates and peaks out. Now, yes, they all follow this S-curve, but they follow it at different rates. The microwave technology, it took many years actually for microwaves to really hit mass adoption. In fact, it took about almost 19, 20 years to hit 80% adoption rate in the US, as opposed to color TVs, which hit 80% adoption rate within 6-7 years. So the idea here, this diffusion model helps me estimate what type of path I will follow for my product. Will it be this fast adoption rate, or will it be a slower adoption rate? And so the typical model that we're going to show here is based on the Bass diffusion model. And this was developed by Frank Bass in the late 60s. And this was based on the idea that there are two effects that drive product adoption. The first is that there's an innovation effect. There are people out there that are ready to adopt this technology early. They place a high intrinsic value on the ability to adopt. They don't care who else is using this technology. They just hear about it and they want to adopt it. These innovators tend to come in and they peak early on in the cycle. They come in early and they kind of peak out early. The other effect is known as the imitation effect. And these are people who hear about the product by word of mouth. They hear it by someone they know and they decide to use it, to adopt it. They're influenced by the behavior of their peers. This is called social contagion. It sounds like a disease, but it's not. The idea is that you hear it from a friend, an associate, and then you decide to adopt it. Imitators come in a little later in life. They peak later than the innovators. Now, this isn't good and bad. This is just two different ways that the communication or the information of a product gets to that individual. In the innovation effect, these innovators, they tend to react based on impersonal information, mass communication. The imitators, they deal with, or they are more receptive to, interpersonal communication or word of mouth. It matters that someone else is using it, and that's how they take the communication. That's how they value that information. So you have these two effects that drive total overall product adoption. So the number of adopters at any one time is really the sum of these two effects, the innovation effect and the imitation effect. And so the number of people, or the size of the market, percentage of the market that's adopted at any time t, is going to be equal to that innovation coefficient p times the remaining size of the market plus this imitation effect, which is the coefficient q, times the percent of the market that's already adopted, because I need to have people already using the technology to give me word of mouth to use it, multiplied by the remaining size of the market. So mathematically I can flesh this out with this equation, which is pretty straightforward once you dive into it. And it's saying the two effects, right? So the number of customers adopting at time t is going to be equal to the coefficient of innovation p times this m. M is the total number of customers who will adopt. That's the total potential market size minus all those who've adopted already. So n sub t minus 1 is the cumulative number of customers who've already adopted by the start of time period t. They're already there. They're using it. So that's the innovation effect. Then the second term is the imitation effect, the imitation factor q multiplied by this term n t minus 1 over m, and that's simply the percent of the market, percent of the total market that's already adopted, and you're multiplying that by the total size of the remaining market who's out there. So how would I use this? Well, let's give a very simple example. I'm trying to estimate or forecast iWidget sales. And Manageit has made some estimates on that it's a 4-year product life, total sales about 750,000 units, and we've already determined what P, 0.1, and what Q, 0.25, that I want to use. Now the shape of the P and the Q determines the speed and the shape of that final S-curve. So I want to project the sales by each quarter. So what am I going to do here? I'm going to take this P, 0.1, multiply it by my market size M, 750,000, I'm dealing in units of thousands, minus my cumulative up to that point is 0, that's the first quarter. The imitation effect is going to be that 0.25 times 0, because no one has adopted it yet, plus or multiplied by the size of the remaining potential, 750,000. And that gives me 75K, 750,000. And then I do the same thing for the next quarter, except now I've got some adopters already. So I go through this, and here's the chart, and I did this for the next 16 quarters. And if you look at the innovation effect, you can see that there's a lot of early adopters here, and they kind of peak very early and then they dwindle off. The imitator effect, though, is it peaks a lot later, right? And then it goes down. So it captures the two different effects here, the early innovators and the latter imitators. And this column here is just the cumulative number up to date for that period, and the NT is just the number of adopters for that specific period. So this is one way that you could use this model. But one of the first questions you're going to ask is, well, where did they come up with the P and the Q? Luckily, this has been studied for a number of years, and there's a lot of studies out there. And so people have looked at different technologies and how they've been adopted, and they've mapped and estimated what the P, the innovation coefficient, and the Q have been for different technologies. And so the idea is you want to find something that's similar to the product that you're going to launch, and you might want to use those similar P's and Q's. So if I look at some of these, you get a sense of the type of product that's being introduced. A high P means you're going to have a lot of innovators, a lot of first movers, early adopters. So look at the home PC as the highest value for P of all these different items, and that's saying that you're going to get a lot of early innovators here, a lot of early adopters. As opposed to, say, curling irons, where I have a very high Q, or for drip coffee makers. What is that saying? Well, that means you're going to have a lot more imitators. They hear about it, they see their friend using it, and they decide to adopt. So the P and the Q, what they do is they essentially balance out the early adopters versus the later adopters. So how would I use this? Well, I want to identify a similar product. And so I showed you different P's and Q's for different items. Up here, I've got what on average a P is a 0.3, a Q is generally 0.38. That's just general values. There's a lot of literature out there for your specific product, but what you want to do is identify something that's similar. And what do I mean by similar? Well, you want to see if you're introducing it in the same environment, whether how it's the socioeconomic conditions, is it similar regulations? You want to understand the market structure that you're introducing your product into. Are there a lot of competitors, or are you the only person out there? You need to understand the buyer behavior. Am I selling to a consumer or to another business? The marketing mix, do I have promotions? How is my pricing set? And then the characteristics of the innovation itself, the complexity of it, the relative advantage over competing products. So the idea, you want to find a product that's similar to the one that you're going to launch. And then you use these estimates to try to get a rough idea of what your trajectory of sales would be. Now, these parameters aren't set in stone. They change over time and they change by regions. Interestingly, certain countries, especially ones that have a stronger socialist fiber, tend to have a higher Q, where there's more interpersonal discussion of things. So there's a higher imitation coefficient. And many countries with higher purchasing power per individual or per household have a higher P. So you have to look at the region as well as the type of product. And then one point to stress, these diffusion models are really good for estimating the trajectory, the percent of sales, not the absolute. Because all that we're estimating is percent of the sales. You've got to estimate, you've got to input the M, what you think the total market size is going to be. But the model does do a lot of interesting things, and it does provide you, for example, an estimate to be able to estimate the time of the peak sales. What time period would I expect to have my peak sales occur? And that's simply equal to the natural log of the ratio of the Q, the imitation coefficient, over the P, the innovation coefficient, divided by the sum of the two coefficients. So this is one way to use the BAS model. Given a P and a Q, estimate what your sales are going to be. But next we're going to use it to forecast demand, but you're going to estimate the P and the Q and the total market size M based on your early observations.